Okay, the next part of the equation is they want to know how fast does the ball hit the ground. Again, it's going to hit the ground going in this direction, and it's going to be going pretty fast because gravity made it speed up. So how do we solve a problem like this? Well, to start with, it's going 12 meters per second when it leaves the cliff. How fast is it going in the x direction? Did anything speed it up or slow it down? No. Still 12. How about over here? Still 12. How fast is it going in the x direction over here? Still 12. So how fast is it going over here? Still 12. Just as it hits the ground, we said 2 seconds later, how fast is it going? It's still going 12 meters per second in the x direction. So we already have one component of the triangle to use with Pythagorean theorem, okay, the component. We have the x component. How about the y component? Well, we start off, you know, as soon as you let something go, it starts off very slowly and picks up speed. So we have to analyze this in the y direction this time. Remember, you got to pat your head and rub your belly across this way. So we're going to do the y direction and we're going to do the x direction. Or should I say, we already have the x direction velocity. We don't have to do that. Let's find out how fast it's going in the y direction. It starts going faster and faster and faster. And finally down here, it's moving very fast in the y direction. How fast is it moving in the y direction? After 2 seconds, velocity final in the y direction is equal to velocity initial in the y direction plus at. Again, why the y's? Because we're dealing just in the y direction. Pretend it's not moving. Just as if you dropped something off the cliff, how fast is it going when it hits the ground? Don't worry that it's moving in that direction. We're going to put them together in a second. Remember, how fast is it going? When we just let it go, it's going 0, so we get rid of that. Velocity final in the y direction is equal to acceleration times time is equal to negative 9.8 meters per second squared times 2.02 seconds. We'll end up with negative 19.8 meters per second. So that's what this is, 19.8 meters per second. Okay, so this is the x component, this is the y component. I want to know what the resultant is. So it's a square root of 12 squared plus 19.8 squared. And we'll end up with 27 meters per second. And what's this angle? This angle is tangent, -1. Opposite over adjacent, which is 19.8 over 12 is equal to 63 degrees. So this is 63 degrees, 27 meters per second. So when I ask you, how fast and in which direction was that ball going when it hit? It was going 27 meters per second at 63 degrees below x